In this video, I will explain how to do this forecasting assignment. So in this assignment, the first question is calculate the 3-period simple moving average using this data. I am using a different data, so please be mindful that this data that I'm going to use in this video is not the same data as in your assignment. So make sure you are using this data that has been given to you, not the one used in this video. So the first question is calculate 3-period simple moving average. And for 3-period moving average, I will be taking average of these 3 period, and because it is forecast is for future, so it is for the 4th period. So I will write my answer here. I will enter my formula here in front of the 4th value. This is a critical point. You cannot start writing your answer here, here, or here, but it must be here. So which mean because it is a 3-period moving average, so you are using data of these 3 period and it's a forecast for future, so it should be here. And I use this formula, is called average, and take average of these top 3 periods, and then you can drag it down up to this point. So this is 11th period, and that has been asked in the question that we need forecast for 11th period. So this is your answer, 71. Let me highlight it and let me expand to 2 decimal places. Okay, here you go. And then the next question is weighted moving average. And for weighted moving average, we have been given these weights 50%, 30%, and 20. And it says use 50% for the most recent, 30% for the next most recent, and 20% for the oldest one. Okay, so in this case, uh, out of these three values, this one is the most recent one. So again, I will be writing here in front of the 4th value because we are already using these 3 periods. So I will multiply 63 by 50% plus this 60 multiplied by 30% plus this 60 multiplied by 20. And the sum of 50%, 30%, and 20% should be 1. And the formula will be this 63 multiplied by 50%, that's 0.5, plus this 60 multiplied by 30%, that's 0.3, plus this 60 multiplied by 20%, that's 0.2. And here you go. And then again you drag it and make sure you drag it up to what point. You need to drag it up to this point, that's 11th, because we have these 10 values and you need forecast for 11th period, so this is your answer. Again, let me expand this to 2 decimal places, so 71.2, that would be your answer. Now the next one is exponential smoothing, and for exponential smoothing you can use either formula or you can use this data analysis function. If you want to use this function that's given here in Excel, that's called as data analysis, and in data analysis you click on exponential smoothing and then click OK, and then it says input range. Our input range is this one, and then damping factor. So in the question it says alpha is 0.2, so damping factor will be 1 minus alpha, so 1 minus 0.2 will be 0.8, so we are supposed to write here 0.8 because this is damping factor. And then it says where you want your answer to appear. We want our answer to appear here, and if I click OK, it will give me this forecast using exponential smoothing. And again I can drag it by 1 point, and that gives me exponential smoothing forecast for 11th period, that's 67.38. We can also do it using manual this formula, and let me show it very quickly how we do it manually. So when we do it manually, uh, make sure that the first one, so 60, there is no value available here because the first forecast will be available only once this first period is over. So for the first period you don't have any forecast, so therefore we just write here 60. And then this is our data, remember, so this is the data that we are going to use, and these in blue, they are your answers. And when this 60 becomes available, then that becomes forecast for the second period, so we write it here. So this is the first step here, whereby the top value will be always will be not applicable in exponential smoothing, and second value will be the top value from your data column. And then in the third one you will enter formula, and the formula is given here is equal to previous forecast. So this is previous forecast plus alpha, alpha is 0.2, and then multiplied by difference of actual, previous actual minus previous forecast. So this is previous actual minus this is previous forecast, and if I hit enter I can drag it down, and you can see here it gives us identical results. So you have this option, you can do it manually or using this function that's given in Excel. Now you can see that both are exactly the same thing. This one I did using this function, that's data analysis and exponential smoothing, and this one I used this formula. So I can delete one of them because they are identical, we don't need both, we only need one, and I would delete one. Okay, now the next one is called as MAD using moving average. Okay, so this is our moving average data, so I'll be using this moving average data to calculate MAD. Now look, note carefully that our first, this is our first data point, so which means that we need to start from here, because this is our first data point and we have to take difference of actual minus this one, so your answer should come here. You cannot start from here because for this one, although we have 60, but corresponding value of moving average is not available. Similarly, you cannot start from here or you cannot start from here, because although we have data point, but the value of moving average is not available. We must start from here because for this point we have both of these points, which means actual data is available and forecast is also available. And the formula is called as absolute difference of 66 minus 61, and if you hit enter and then drag it, now make sure that you drag it only up to this point because this is not forecast. So you only drag it up to this point. In this case we had to drag it up to 11 because this is forecast, this is not forecast. So make sure that you drag it only up to this point and then take your average of these values. So this is our MAD, and again you can reduce number of decimals, it will become 2.76. Again please note here that one of the critical thing is that where you are starting from and where you finish. We are starting from here, because we have to take difference, and here two values are available, so we can take their difference. We cannot take difference of these two because a value is not available here. So we start from here and we stop here, and we stop here because again here we have actual data and our forecast. So for this one we don't have actual data, so therefore we cannot take difference, so therefore we need to stop here. And this is called as mean absolute deviation using moving average data. Now I will do the same thing, but I'll be using weighted moving average data, and for that one again I'll be use the same formula is equal to absolute 66 minus, but this time I'm using weighted moving average, and if I run it and if I drag it, and here I will take average, and the average turns out to be, just make sure that spellings of average are correct, and average turns out to be 2.31. And let me reduce number of decimals. Okay, and the last one is um, mean absolute deviation using exponential smoothing. So now I will be using this data. Now in this data, where our first data point is available, so our first data point is here. So I can start from here, because here we have this actual data and forecast data is available. I cannot start from here because here we do not have data point, it's not applicable. So I will start from here, and that will be is equal to absolute 60 minus this forecast, and then you can drag it, and remember you have to drag up to this point, and then here you will take average, and that gives us 4.10. And let me just do it one more time. Here is equal to absolute of this one minus this one, and when we drag it, so we get this one, that's 4.10. Okay, and then the next one will be MSC. In MSC, again, because we have this data point from here, so I'll be entering my formula here, and MSE is called as mean squared error, which means it's the difference of 66 minus 61, because this is moving average, so I'm using data of moving average. And then press shift 6 and power 2. So this is how you take it, and then drag it down, and again make sure you drag it only up to this point. And if I take average, so this gives us about 9.81. Okay, and now let's proceed to MSE using weighted moving average, which means I want to compare my actual forecast against weighted moving average. And again, because the first data point is available here, so I must start from here, is equal to take a difference of 66 minus weighted moving average, and then take it square by pressing shift 6 and then 2, that which means power 2, and then again drag it, and remember you have to drag it up to this point, and then take average. And if you take average, that gives us something, if 7.59, or if I reduce decimal places, I get 7.60. Okay, and the last one is regression analysis. And for regression analysis, we don't need anything here. It will be, because there is just one value, and maybe I can enter here all not applicable. So for regression analysis, we'll be using a function that is in data, go to data, and then data analysis, and then here you will find regression. Here is regression, select that, and it says where is y range. So this is our y range. Let me show you, this is our y range, this data is our y range. And it says where is your x range. X range is this years. And then it says where do you want your results to appear. I want my results to appear here in this place, so I write M. I just select that column, and then when I click OK, that gives me regression results. Now there are many things here, but the most important thing that we need is this one, and that is adjusted R square, and I will convert it into percentage by clicking on this one and expand to two decimal places. So shows that it's 92.51. So that is our r square. Now the next thing is that once you are done with all this, then all these answers, they must be transferred to a word file that will be uploaded on Blackboard. So for example, let's say this is moving average, and I will copy this one here, and then I will go to weighted moving average. I will copy this one and I will paste it here. And again, make sure you are pasting them at the right place. You see, the top three cells are empty, so top three cells must be empty. And then for exponential smoothing, I'll be pasting all these here. Okay, and for r square, we just calculated it here. It was 95.21, and I can paste it here. There's only one value, 92.51. And the next one is MAD for moving average. Now MAD for moving average, again I can copy this one. I just need to make sure that there are unequal spacing. Here is an extra row. There is no extra row, so I need to uh, copy paste them separately. And this is 2.76, 2.76. And then for MAD for weighted moving average, I copy this separately, and our answer is 2.31, so I will write here 2.31. And for this one, and that is MAD using exponential smoothing, I will copy it separately, and it is 4.10, so I will write here 4.10. And for MSE using moving average, I will copy this part first, and our answer is 9.81. And in the last one, that's MSE using weighted moving average, I will copy this one separately, and I will copy paste it here, and our answer is 7.60, so I will write here 7.60. So that's all about how to solve this assignment. Again, if you ask me what's the critical thing here, the critical thing here is to be mindful where you are putting your values. This is moving average, 3 period moving average. You are using data of 3 periods, so your answer must be in front of the fourth one, because you already have data for 3, so you cannot make a forecast for something that's already available, so it must be for the fourth one. So therefore you start from here, and because we need forecast for the 11th period, so you drag it up to this point. Then weighted moving average, exponential smoothing. And also note here that in this case we are not taking any averages here, but we do take averages for MAD and MSC. So this is something, these are forecasting technique, and these are the techniques that are meant to measure which technique is better.